It's 2 a.m. on a Tuesday. Somewhere in a data center, maybe Virginia, maybe Frankfurt, maybe Singapore. It doesn't really matter. A server hums quietly in the dark. It's been running for years. Nobody thinks about it much, it just works. It has always just worked. A network request arrives. Nothing unusual, just a small data packet, routine traffic. The kind of thing that happens tens of thousands of times a day on a machine like this. Except this one is different, because the thing that sent this packet isn't a hacker sitting in a dark room somewhere. It isn't a government intelligence agency. It isn't a crime syndicate. It's an AI, and it isn't guessing. It isn't rattling locks hoping something opens. It already knows exactly which window is cracked. It already knows exactly how to reach through it. Already has a plan. In about 4 hours, it's going to have the keys to the entire machine. No password, no login, no alarm, no one to stop it. Here's the part that matters to you. Not a company, not a government, to you. Because the machine it's about to unlock, it doesn't just store data. It stores someone's life, photos, messages, credentials, access. The internet doesn't break all at once. It breaks one quiet machine at a time. Let me tell you about a piece of code. It was written in 2009. Think about what the world looked like then. Barack Obama had just been inaugurated. Bitcoin had just been invented. Most people had never heard the word cloud computing. The iPhone was only 2 years old. The idea that an artificial intelligence would one day read your code and find your mistakes faster than any humans could was science fiction. The kind of thing you'd laugh off at a conference and go back to your desk. Someone sat down in 2009 and wrote this code. Probably a good engineer, probably careful, probably proud of the work. And it shipped into FreeBSD, one of the most respected, battle-tested operating systems on the planet. Not some hobbyist project, not a startup's weekend experiment. FreeBSD is the same operating system that quietly runs inside your PlayStation, the same one that powers Netflix content delivery, the same one Apple borrowed from heavily when they built macOS. The operating system on the laptop you might be watching this on right now. And that code just sat there for 17 years. Think about it. Think about what 17 years means in technology. Entire companies were born and died in that time. Smartphones went from novelty to necessity. Social media reshaped democracy. We got a global pandemic. Multiple generations of programmers entered the industry, learned their craft, and started reviewing this very codebase. Millions of eyes passed over it. Professional security audits, the expensive kind with consultants who charge more per hour than most people earn in a day. Bug bounty hunters, competitive, motivated, incentivized to find exactly this kind of thing. Government-funded security reviews, academic researchers writing papers, open source contributors who dedicated years of their life to making software better and safer. Not one of them caught it. Not because they're lazy, not because they were incompetent, but because the bug was subtle. It was the kind of mistake that, when you finally see it, makes you understand how it was missed. It wasn't a flashing red warning sign, it was a quiet flaw, buried in logic that otherwise looked perfectly reasonable. It sat in the NFS server, the part of FreeBSD responsible for file sharing across a network. The kind of foundational infrastructure that nobody glamorizes. Nobody writes blog posts about NFS servers. Nobody gives talks about it at conferences. It's just there doing its job. Invisible and unremarkable. The way the best infrastructure always is. And here's the uncomfortable truth about making invisible, unremarkable infrastructure. Nobody checks it twice. And if you've ever assumed that someone somewhere is checking all of this, this is the moment that assumption starts to fall apart. It was written once, it worked, it passed reviews, it shipped, and then the entire industry collectively decided it was someone else's problem and moved on. The bug didn't announce itself. It didn't cause crashes. It didn't throw errors. It just waited, patient in a way that only a flaw in software can be, for someone to come looking. For 17 years, nobody did. Because up until now, this kind of bug had one natural predator: time. Eventually, someone would find it. But what happens when something finds it first? Now, before we get into what happened next, I need to tell you about a leak. On March the 26th, 2026, two researchers, Roy Paz from Layer X Security and Andre Pauwels, and I'm sorry if I've butchered your names, from the University of Cambridge, were doing what security researchers do: poking around, looking for things that shouldn't be exposed. They found something: a configuration error in Anthropic's content management system, the software the company uses to manage its blog and public-facing documents. Had left nearly 3,000 unpublished internal assets sitting in a publicly searchable data store. No authentication required, no password. Anyone who found the right web address could read them. Among these documents was a draft blog post announcing a new AI model. The media outlet that first broke the story was Fortune magazine. What the documents described was striking enough that the story spread immediately across the tech press and well beyond it. Cybersecurity stocks dropped sharply within hours, driven by investor concern about what this model could do to the industry. The model's internal code name was Capybara. Its public name was Claude Mythos. Anthropic confirmed it. It was real. And then, 11 days later, on April the 17th, 2026, they made full announcement on their own terms. But what they said when they finally said it officially was remarkable. They had built something new, something genuinely unlike what had come before. And in the same breath as announcing it, they should have said something that should have made every headline in the world. They were not releasing it. Think about that, just for a moment. An AI company builds something, decides the world shouldn't have it, and tells everyone about it anyway. That's not a publicity strategy, that's a warning. And companies don't usually hold back powerful technology. Not in this industry. Not unless releasing it would change something in a way they can't control. Because here's what Anthropic said in their own words. The model presages our upcoming wave of models that can exploit vulnerabilities in ways that far outpace the efforts of defenders. This wasn't marketing language. This was a company telling the world, we built something that scares us. What made Mythos different from every AI model that came before it wasn't just that it could find security vulnerabilities. Lots of tools can find vulnerabilities. What Mythos could do was take a vulnerability it found and turn it into a working weapon, autonomously, without a human in the loop guiding it through each step. You give it a target, you give it a single instruction, and then you go to bed. You wake up the next morning and there's a working exploit waiting for you. The whole process, reading the code, understanding the system, identifying the weakness, constructing the attack, testing it and refining it, delivering it, running in hours for less than $50. To put that in context, historically, building a working exploit from a known vulnerability took a skilled security researcher days, sometimes weeks. It required deep expertise, creativity, persistence, and a fair amount of luck. It was the kind of work that only a small number of people in the world could do at the highest level. Mythos does it while you sleep, at the cost of a nice dinner, which means the barrier isn't expertise anymore, it's access. And access doesn't stay restricted forever. But this is where the story stops being clean. Because when something this big drops, the truth doesn't arrive neatly packaged. It arrives messy. Now I know what you're thinking. Tell me about the hack. Tell me what it did. And we're going to get there, but stay with me for a moment because there's a wrinkle in this story that most coverage completely ignored. And if I skip past it, I'm not being honest with you. Here's where the story gets interesting and a little contested, because the FreeBSD vulnerability, officially catalogued as CVE 2026-4747, didn't appear out of nowhere. When Anthropic unveiled Mythos on April the 17th, it had already publicly disclosed 12 days earlier. On March the 26th, the same day as the accidental leak, FreeBSD's security team published an advisory for the bug, crediting Nicholas Carlini using Anthropic's Claude. Nicholas Carlini is a research scientist at Anthropic, and the Claude model he was using was Opus 4.6, the previous generation, not Mythos. 3 days after that advisory was published, a research group called Caliph.io asked their own Claude instance to build a working exploit. It took about 4 hours of the model's actual working time. Both exploits that Claude wrote worked on the first attempt. So by the time Anthropic launched Mythos and held it up as a demonstration of the new model's capabilities, the bug had already been found, reported, patched and exploited, all using older, already available tools. Some critics in the security community have argued presenting this vulnerability as a Mythos discovery was, at best, sloppy, and at worst, deliberately misleading. One security blog called it a marketing trick. Anthropic's own Mythos post does say the model fully autonomously identified and then exploited the vulnerability, but the timeline of the official record tells more of a complicated story. Anthropic hasn't publicly clarified whether Mythos independently rediscovered a bug that the previous model had already found, or whether the launch materials attributed the earlier model's discovery to the newer one. That's a real and legitimate criticism, and we should name it rather than bury it, because if we don't separate what's real from what's exaggerated, we risk missing the part that actually matters. But here's the thing, even if we set that specific controversy completely aside, even if we assume the worst case interpretation that this example was overhyped, the broader picture of what Mythos can do is still supported by independent evidence, and that picture is genuinely alarming. So strip away the headlines, ignore the marketing, here's what we know happened. So let's set aside the dispute and look at what isn't in question, because even without the FreeBSD example, what Anthropic's testing revealed over the course of a month is genuinely extraordinary. Anthropic's researchers, in their own testing over roughly a month, pointed Mythos at some of the most critical and well-reviewed software in the world. The setup for each test was the same: a self-contained environment, a Claude code instance, a single paragraph instruction to find security vulnerabilities. Human involvement ended there. The results, across multiple targets, were consistent. In OpenBSD, an operating system built from the ground up with security as a single obsessive priority, reviewed more aggressively than almost any software in the world, Mythos found a vulnerability that had been sitting there since 1998, 27 years, hidden in the code that handles internet connections, meaning it could potentially be triggered by any machine communicating with an OpenBSD server over the internet. In FFmpeg, the open source media library that processes video on billions of devices, including almost certainly the one you're watching this on, Mythos found a bug introduced in a 2003 update and made worse by the 2010 change to the code. Automated tools had run on the vulnerable section of FFmpeg over 5 million times without flagging anything. Mythos caught it by reasoning about what the code was trying to do, not just what it was doing. In web browsers, every major one, Mythos identified thousands of potential vulnerabilities. In one documented demonstration, it chained 4 separate bugs together into a single exploit that escaped the browser's security sandbox entirely. On the Firefox JavaScript engine specifically, the comparison to prior models is stark. The previous best model produced 2 working exploits from several hundred attempts. Mythos produced 181 against the same targets. And then there's the number that Anthropic buried at the end of their technical report, almost as an aside. Over 99% of vulnerabilities they have found have not yet been patched. Meaning right now, as you're watching this, some of those vulnerabilities are still sitting in live systems. That's not theoretical, not future risks, present tense. To be clear about what this means, it's not that patches don't exist, it's that bugs are still under responsible disclosure. Anthropic is working with affected vendors to fix things quietly before publishing details that could help attackers. These patches are coming, but they aren't here yet, which means right now in production systems around the world, there are vulnerabilities that an AI found, some of them decades old, that remain open. And this is the point where it is easy to blame someone, a bad developer, a missed review, a failure somewhere in the system. But that's not what this is. I want to pause here and talk about the people in this story, because it's easy to turn this into an abstract horror story about systems and vulnerabilities and AIs. But there are humans at the center of this. Think about the engineer who wrote that NFS code in 2009. They didn't know. They were doing good work on an important project, trying to build something reliable and useful. The FreeBSD project is built almost entirely by volunteers, people who do this in their spare time because they believe in it, because they care about it, because they want to contribute to something that lasts. And for 17 years, that contribution held up. It ran in production servers around the world. It helped power PlayStation consoles that brought joy to hundreds of millions of people. It sat inside Netflix's infrastructure while people watched their favourite shows. It did its job. The bug wasn't laziness. It wasn't negligence. It was the honest, unavoidable fallibility of human beings working on a frontier of complexity. And now think about the security researchers who spent careers looking for exactly this kind of thing, who developed their skills over years, built reputations, took pride in their ability to find what others had missed. Not because they wanted to cause harm, the opposite, because they genuinely believed in finding these things and fixing them made the world safer. Nicholas Carlini, the Anthropic researcher whose name is on the FreeBSD advisory, said something at the launch briefing that stuck with a lot of people who heard it. He said, "I've found more bugs in the last couple of weeks than I found in the rest of my life combined." He's been a professional security researcher for years. Those people did not fail. They were doing something genuinely hard with the tools available to them, under constraints of the human attention and human time. What changed wasn't their competence. What changed was the nature of the tools they're now working alongside, and that's a much harder thing to sit with. And when the tools change faster than the people using them, the ground shifts underneath everything. So the obvious question becomes, if this thing is real, who gets to use it? When Anthropic announced Mythos, the announcement came packaged with a solution. They called it Project Glasswing, named after a butterfly with transparent wings, a restricted coalition of founding partners who would receive access to Mythos specifically for defensive purposes, finding and fixing vulnerabilities before the bad guys find them first. The partners read like a guest list for a meeting of the internet's landlords: AWS, Apple, Broadcom, Cisco, CrowdStrike, Google, Intel, JP Morgan Chase, the Linux Foundation, Microsoft, Nvidia, Palo Alto, and Anthropic itself. Over 40 additional organizations also received access. Anthropic committed $100 million in usage credits and $4 million in direct donations to open source security organizations. By any measure, a serious commitment. Now, I want to be careful here because I think this matters. Anthropic framing this as a safety decision is not unreasonable. The argument is straightforward. Mythos is too capable to release broadly. In the wrong hands, criminal hands, hostile governments, anyone who wants to cause harm, it would be catastrophic. So instead of releasing it, Anthropic is deploying it defensively, finding and patching vulnerabilities before they can be weaponized. That is a coherent position. It might even be the right one. Who's to say? It's not for me to say. It sounds responsible. It might even be responsible. But responsibility and power tend to travel together. But let's also name what else just happened. Before April the 17th, 2026, the question of who gets to find and fix the internet's most critical security vulnerabilities was distributed, spread across thousands of researchers, companies, government agencies, academic institutions, open source communities, messy, inefficient, sometimes duplicated, but distributed. After April the 17th, 2026, one company holds the most capable, publicly known tool for doing that job. And every major player in the technology industry, including companies that in any other context are Anthropic's competitors, signed up to their program. Not because they were forced to, because the alternative, not having access to Mythos while others did, was a position nobody wanted to be in. Jim Zemlin, chief executive of the Linux Foundation, put it plainly, because the dark side of AI augmented security is AI augmented insecurity. We must ensure that access to the best AI cybersecurity tooling is evenly distributed. That's an interesting sentence to say at the launch of a program that by its definition is not evenly distributed. And when access to security isn't evenly distributed, neither is safety. Anthropic didn't engineer this outcome deliberately, but power flows toward capability. Always has. And whoever controls the best vulnerability finding AI controls the security posture of the entire software industry. One company now sits at the center of that. And the remarkable thing is that the rest of the industry handed them that position willingly in the space of a single press cycle. That's not a conspiracy. It might even be the right outcome. But it's worth noticing what just happened. Because this isn't a one company story. It's a trajectory. Here's the part that actually keeps security researchers up at night. Mythos is Anthropic's model. It's restricted. It's being supervised. The people running it are, best anyone can tell, trying to use it responsibly. Project Glasswing partners have been scanning their own infrastructure with it for weeks, quietly finding and patching vulnerabilities that have been hiding for years. That part is genuinely good news. But Mythos is not a unique phenomenon. It's a capability milestone, a point on a curve that the entire industry has been climbing upward for 10 years. And that curve doesn't stop at Mythos. Researchers at an AI cybersecurity firm called ISLE decided to test this. They took the FreeBSD vulnerability and tested it against small, publicly available AI models. Models you can download and run yourself. Models available to anyone with a laptop. 8 models. 8 for 8 detections. Which means this isn't rare anymore. It's repeatable. One of those models had 3.6 billion parameters and costs 11 cents per million tokens to run. Mythos is the frontier, but the frontier moves. Other AI labs are building towards this capability level. Estimates range from 6 months to a year before comparable models exist. And unlike Mythos, not all of these labs will choose not to release theirs. At the same time, the organisations that run systems being targeted are not moving at the same speed. A 2025 report found that over 45% of discovered vulnerabilities in large organisations remain unpatched after 12 months. The Cisco security chief, speaking at an industry conference, confirmed the on-the-ground reality. If you talk to an operational team and many of their customers, they're only patching once a year, and frankly, even in the best of circumstances, that's not fast enough. So now you have 2 clocks running against each other, one measured in minutes, the other one in months. The CrowdStrike threat report from earlier in 2026 found that criminal groups can now move through a compromised network in under 30 minutes on average, 65% faster than 2 years ago. AI augmented attacks had surged 89% year over year. The gap between how fast attacks can happen and how slowly defences respond isn't closing, it's growing. And somewhere in that gap, sitting quietly in the dark, are thousands of vulnerabilities that Mythos found and flagged and nobody has fixed yet. A 17-year-old bug, written by someone trying to do good work in a project built by volunteers who cared, deployed into infrastructure that hundreds of millions of people depend on without ever thinking about it. Reviewed by the best minds in the industry, missed by all of them. Not because they were careless, because it was hidden. And human attention is finite, and there is always more code than there are eyes. That bug, it was found, whether by Mythos or by the model that preceded it, or eventually by something similar and cheaper still, by machines that don't sleep, don't lose focus, and don't decide some section of code is probably fine and move on. The FreeBSD vulnerability has a patch now. The hole is being closed. This time. But the story of how we found it, the leak, the controversy, the rushed announcement, the coalition of tech giants scrambling to get access to the tool before someone used it against them, tells us something about the moment we're in. This isn't a story about one bug. It's the story about the end of an era. The era where human eyes were the primary way we found these things. When the gap between finding a vulnerability and weaponizing it was wide enough for defenders to breathe, that gap just got a lot narrower. There are thousands more findings in the queue. Vulnerabilities from the 1990s, vulnerabilities introduced before some of the engineers who are currently maintaining those affected software were even born. Bugs that have been running in production, silently, patiently, waiting. The cursor is still blinking. And for the first time, we're not the fastest things looking for those bugs anymore. The next packet is already on its way.